Have you ever taken a beverage? Coca-Cola, for example. Information on nutritional content is given on the bottle. And take Food X, for example. It can be written on the bottle that the beverage has 2.8 milligrams per 100 grams of Food X. This and more in calculating the percentage by mass of a substance in a compound. When you are given the mass, or when you know the relative formula mass of the compound you are dealing with, then getting the percentage composition can't be that hard. Let's look at percentage of substances in terms of tomatoes. In a group of 8 tomatoes, if 2 are green, then it means that 2 out of 8 tomatoes are green. In other words, 2 out of 8 times 100%. It means that 25% of the tomatoes are green, and then the other percentage, which is 75% of the tomatoes, are the other color. Now let's look at an example of percentage by mass. Calculate the percentage of nitrogen in nitric acid. And in brackets they tell us that H is equal to 1, N is equal to 14, O is equal to 16. In my previous videos I've explained what these figures given in brackets mean. They actually mean the atomic mass of the elements present. The first thing we need to know is the relative formula mass of nitric acid, which can be calculated using the atomic masses of the individual elements present. That is 1 times 1 for hydrogen plus 14 times 1 plus 16 times 3, giving us the relative formula mass of nitric acid as 63. Then the mass of nitrogen in nitric acid, it actually means that nitrogen is appearing once, which is 14 times 1, and then the mass of nitrogen in nitric acid is 14. Then the percentage by mass of nitrogen in nitric acid is then got 14 divided by 63 times 100%, which will give us 22.2%. Let's look at example 2 where we are calculating the percentage of sodium carbonate in a hydrated sample of sodium carbonate. The hydrated sample of sodium carbonate has a formula of Na2CO3.10 water. And in brackets they've given us Na is equal to 23, O is equal to 16, C is equal to 12, and H is equal to 1. The first thing we need to know is to know the mass of the hydrated sample, which is 23 times 2 plus 12 times 1 plus 16 times 3 plus 10 times 1 times 2 plus 10 times 16 times 1 to give us 286. That is the formula mass of the entire hydrated sample. Then the formula mass of the sodium carbonate that we are interested in, it is 23 times 2 plus 12 times 1 plus 16 times 3, and that gives us 106. So the percentage by mass of sodium carbonate in the hydrated sample is 106 divided by 286 times 100, and that's how we come up with 37.06%. So that's how we calculate the percentage by mass of a given sample in a given compound. Thanks for tuning in, and at the end of this exercise we've left some exercise for you to try out and see if you've mastered the concept at heart. This is Kagena Kenneth, and don't forget to subscribe and share this video, and thanks for tuning in.